So now let's continue talking about sort of basic probabilities. So let's say you have a bag with 20 cherries, 14 of which are sweet and 6 sour. If you pick a cherry at random, what's the probability it will be sweet? So again, we say, how many ways can, out of all of the outcomes, how many ways can our event occur? In this case, in order to be sweet, there are 14 ways that we could end up with a sweet cherry. Out of how many possible outcomes? Well, there's 20 possible cherries that we could have picked. So there's a 14 out of 20, or 7 out of 10, or if you wanted to, you could also say 70% chance, or probability that our cherry will be sweet. Now that is, of course, assuming that all of our cherries are actually the same in shape and size. If they happen to look different, then that might not be the case. Let's look at another one. Let's find the probability of randomly drawing one card from a standard deck of cards and getting an ace. Now, if you're not familiar with a deck of cards, here's what they look like. There are 4 suits. This top one is called a spade, and then diamonds, clubs, and hearts. There are the numbers 2 through 10, an ace, which sort of corresponds with a 1, and then these 3 are called face cards, the jack, the queen, and the king. So the question was, compute the probability of randomly drawing one card from a deck and getting an ace. Well, again, we would need to say how many ways can that event occur out of all the possibilities. So there are 13 different cards for each of 4 suits. So there are 52 possible cards in the deck. Out of those, how many of them are aces? 1, 2, 3, 4. And so there is a 4 out of 52, or 1/13th, or if you wanted it in decimals, you could say 0.0769, or about 7.69% probability or chance of randomly drawing a card from the deck and getting an ace.